I've had the misfortune of being sick and needing about 6 liters of IV fluid over the past week. My situation would have been far worse if I were an astronaut, seeing that the current methods of IV administration do not work in space, and I would have had to go to another planet for treatment. Mindful of this problem, we decided to put a medical twist on the question: how might we demonstrate how the movement of fluids through a pressurized system changes in microgravity?
In order to see how microgravity would affect IV flow, we had to design an IV that would work in space. This includes a peristaltic pump, tubing, and a flow rate sensor. By running water through the flow rate sensor, we can see how microgravity affects the flow rate.
So here is the CAD for our design. As you will see shortly, it consists of the peristaltic pump, the flow rate sensor and 3D printed base, the tubing, and the Arduino and data logger.
We hypothesized that if we use a peristaltic pump that eliminates all air bubbles from tubing, our IV system will dispense a fluid at a constant rate in microgravity, therefore making it viable for medical treatments in space.
One of the most impactful things learned from this experiment is the importance of determining your objective. For a while, we were stuck between two ideas, and our design suffered because of it. Once we settled on IVs, we were able to create a cohesive experiment, and we were able to better work together as a team.
With the future of space travel in mind, and the ever-growing interest in commercial space activities, healthcare and microgravity is an important field of development within space. Companies like SpaceX and Blue Origin both intend to reach goals like further space travel and even one-day colonization. Our experiment will impact the capabilities of healthcare in space for astronauts and future space travelers.
Now, we might be far from interplanetary colonies, but as space becomes more and more accessible, space healthcare will become more and more vital. Our box may be small, but it could one day lead to advances that could save a person like Charles's life.